All right. So my name is William Pagnon. I'm the CEO of Friends Robotics. Our company I've now run for about 11 years. And what we are all about is to merge applied R&D and existing technology to be able to provide innovative solutions that are functional and reliable, particularly in the industry. Doing so over the years, we have merged ourselves a lot about within the fourth industrial revolution, which have been taken a lot to the clouds, have a lot of network interfacing between different machinery in the factory in particular, but as well much more interaction between people themselves and often the fourth industrial revolution, it's all about connectivity. Now, there is some key technology that create this, how you say, ecosystem to be able to communicate and strive. Well, one is the intelligence part, which is automation, being able to adapt yourself to the environment. The other one is to have a proper protocol to be able to communicate between all the system and being able to send messages to diverse area and that can be like through all different system softwares that handles that for you. And the other part is to be able to be flexible in what you manufacture and being able to have a small cost difference between something that you manufacture for 1,000 parts or 10 parts. So that is really the challenge of the fourth industrial revolution. Now, if we look into Queensland, the manufacturing sector is incredibly how you say, small in terms of people that work in it in Queensland. These are like 168,000 workers estimated in 2016, 2017. One of the most important facts is that they actually more than 48% of the manufacturer that are just sole traders, pretty much. Or if they PTY LTDs, they don't employ someone else, just contractors. Now you have the rest of the company, like I think it's about 45% or something like that, that are under 20 staff. As you can see, like basically give a total of 93% of under 20 staff. In those circumstances, automation is very costly. There is not a really good return on investment unless you are doing hundreds and hundreds of parts or thousands and thousands of parts. And that's a big problem. And we saw over the years robots that got invested in taking the dust in the factory, not being used because it was more costly to keep trying to get it working for the task. Cause of the setup time, cause of the request to be dependent of engineering firm like we are, and so forth. Now, Queensland is in growth. It's growing more and more. The Regional Australian Institute estimate that that's going to grow to over 20% likely in terms of demography. Now, speaking about e-manufacturing, this is a kind of the system that most of manufacturers got. There's some icons there that show input and outputs for the good from raw material to finished products, and that have a certain flow. And if you can see in cyan there, you have the good flow, and in a black is all the information flow, and all that need to be connected between the ERP, MRP, and so forth. The things is that we're still in an early stage there, and there's a lot of products that propose one piece of the puzzles or another, but not a full solution. And when you really want to go from 3.0 to 4.0, you have to have a lot of process in place. It's not just about putting some robots in your factory. And so you have to be clever about your KPI, how innovative is your project. There's more and more demand for technology complex system. The reliability and affordability of the machinery is very important, and we go more and more towards what we call robotics as a service. So you can rent it like a car, basically, and you can buy it off in the long term if you're happy with it. Products with a high-level design, it's more complex. The task is to do more this to take in account and develop, and of course, it's increase the cost. Now that's our solution. We over the years develop heaps of little bits and pieces. I'm going to show you a bit of our journey on a video there. And basically, we have developed something that we call framework, and there's two main parts. One that is focused on the factories, the other part which is focused on the information data management and data extraction. Basically, it's systems that can be a turnkey solution installed to the client, but as well can be flexible and being retrofit to any type of robots that taking the dust and make them smart. Add them some eyes, so we work a lot with the vision and being able to understand the robot path and how everything's work together. Basically, the trick that we have is that the setup time is not anymore a burden. So if you want a new product to be done, like 10 parts, you can teach the system either through hand teaching with a collaborative robot, if you have a collaborative robot, or using a pen and trace where you want the process to be done by the robots. And the third option is directly an engineer that can, like you will load a 3D printer, they will load a CAD file with the feature highlighted that need to be processed by the robots. And that include a lot of cloud system, communication, maintenance, monitoring, quality control, extracting all the different data, understand the throughput, and improve as you go. Now I'm just going to change to the video. Now, in this video, I show you just a few examples of things that we do. Basically, again, we are a service company. We develop anything that is related to mechatronics engineering. And we have a mix between industry application and R&D application. We work for startup, but we work for corporate. We work for a lot of manufacturing company. So those are some examples about some automation where we started to look to user vision, and then we went into the collaborative robot world, become a distributor for Universal Robots, and looked at exploring different applications that use natural interface. So as you have seen before, that was using a lot of haptic sensing to be able to control the robots. Now we look as well at like with this lip motion, for instance, to be able to teach the robots by hand the program, and then the robot can replicate the program. Same thing, some tests with the welders there, the welder look at the part and being able to remotely control to develop the program. One of the problems we found there is that having the hand hanging in the air, it's actually really tiring. And then defy the purpose. So instead, we went to more like hands in, grabbing the robots and moving around, having a more gravitational field that attracted to each different feature. Here you can see that was at ICRA a few years ago, and demonstrated how to use a robot on multiple working area. As well, like those are just example of some vision recognition, but that's where you can combine actually the interaction of people and the manufacturing of part, of course, not always necessary. Here, for instance, the robots go to the next part to be done. Of course, yeah, it was an expo, so we was using it again, vision, to be able to detect where those cubes was, and could randomly position where you wanted, and of course it does the process. Here's more live application for page stainless. We still use vision as well, but a fixed vision at the top. One of the challenges they had was to have those grid to be welded at different pitch and angles. As well, another vision application for food factory with bread going through the conveyor and detecting orientation and position. And that can be applied, of course, to all different industrial systems, such as this classic palletizing and all different robots. Now back to the R&D, you can see that we have developed a lot of vision recognition algorithm over the years on different program for different applications. And as a result, basically, we have slowly built up our IP to be able to add a lot of smarts, not only for a custom prototype like this lawn ball detection that tracks that, but as well for all different system that we need to be able to adapt to the environment as a proper robotic system, having the sensor and the actuation and the processing all in sync. This previous one as well, it shows that there was 5 different brain working together, like 2 robots, PLC, safety PLC, as well as the HMI, and it's a skill as well to get also communication work properly. Another example of industrial application, robot bender, where there is interaction with other machines, and being able to again have a proper communication between each other, and have different axis to work with. So all this experience over the years have allowed us basically to be able to have expertise, and as well being able to develop this new framework. That's another example on the same video of tool changing as well. That it's actually essential when you want to work on complex parts. So this is framework simulation where we can scan the part, recognize the part, we extract all the features of parts, and then what we do, we can compare with a scan from a CAD or from an initial scan that was your original parts. And that allows us to be able to put the part to be manufactured at different position. It doesn't have to be on the right angle or the right position. And the interface, we try to make it as intuitive as possible, as well as having buttons on the robot itself to be able to, for example, here to start the well. Here are some engineers that looking at some trajectory. And that's actually, we just received some of the parts. So this is going to be put at the client in February, and um, we are waiting for some of the final aluminum part. And in the meantime, we are 3D printing them. This is the frames that go around it. And finally, the last bit is to show you a brand that we developed specifically to respond to the clients, as freelance robotics was considered freelance, but we are already 9 in the company now. So we have decided to develop industrial robotics that will answer exactly this specific need for the manufacturer. And this little video just show you that it's what we provide in terms of customizable. We provide a report. We discuss with the client. We don't lock the system so that the client is able to change it if you want. There's a lot of flexibility. They don't need to program anymore. They don't need a programmer anymore. A welder can just teach the robot to weld, and it will weld. And so forth. So the other things as well that we provide as a service is the human resources around the project assessment. We have a in-house psychologist that is able to provide smooth integrated robots, because one of the other side why the robots are not used is because the people are intimidated about it and want to and want basically to not having the robot because they're afraid that it's going to take their job and all that. And we're looking more at upskilling. When we integrate robots, we try to make sure that the employment are preserved. And there is a full ecosystem around it. ARMHub, you would hear from it, and AMGC, all the hubs for manufacturing is starting to develop in Queensland, and it's a great thing. That's it for me. Do you have any questions?
All right. Let me see. Am I on? Yeah. William, thank you so much. Thanks so much for your time and for sharing all this interesting information.
Yeah, you're welcome.
We do have a couple questions. First, I have a comment. Very nice to see that Freelance Robotics Dragon is in a Christmas mood. I saw that in the background. The Christmas hat. That's cool. And apart from that, you showed a lot of different technologies and a lot of different applications. What's your biggest deployed technology if it's not confidential?
Well, so some are, but basically the biggest technology is this framework system that we are working on and putting it together. But we have as well autonomous navigation system in terms of size. We have a irrigator of 500 meters that can be remotely controlled from here, autonomously go up and down the field. We have work on different systems. So France is a freelance robotics autonomous navigation system. It's a low-level automation. That's a product actually that we're going to roll out, and we have worked a lot, and there's a lot of IP integrated in that allow from SLAM to GPS guidance, to dead reckoning, complex spikes planning, avoidance in a quite a small system, and we will provide an hardware plug and play so you can adapt to it. Again, we're just starting to look into product. We mainly service companies, so we design for clients.